In 1993, three engineers met in a roadside diner with a simple idea: make computer graphics faster for video games. They had no way of knowing that 3 decades later, the chips they built for gamers would become the engine behind artificial intelligence, powering everything from ChatGPT to autonomous robots. This isn't a story of inevitable success, but of a long shot, a multi-decade gamble by a small company that dared to bet against the giants, repeatedly, until the entire world caught up to their vision. How did a company obsessed with pixels and polygons, born into a cutthroat industry, transform itself from a niche hardware maker into the undisputed backbone of the AI revolution? The answer lies in a series of unpopular, even financially questionable decisions, made years before anyone understood their true value. To understand NVIDIA's audacious journey, we have to rewind to the dawn of the digital age. In the 1850s, the telegraph first created a global digital network, making information travel faster than humans ever could. Then came the transistor in 1947, invented at Bell Labs, laying the groundwork for every modern computer chip. Integrated circuits followed in 1958, making complex semiconductors possible. And by 1971, Intel released the 4004, ushering in the microprocessor era, where Gordon Moore's prediction of exponential growth became an industry mantra. But while CPUs rapidly advanced, one visual frontier remained largely untouched: real-time 3D graphics. This was the Wild West of computing in the late 1980s. Industries like CAD, flight simulators, and scientific visualization desperately needed better visual processing, and dedicated graphics chips began to emerge, clunky and expensive as they were. Jensen Huang, Chris Malachowsky, and Curtis Priem saw a different future. They envisioned a world where stunning 3D graphics weren't just for specialists, but for everyone, especially gamers. So on April 5, 1993, they founded NVIDIA, reportedly discussing their plans at a Denny's in San Jose, aiming to make real-time 3D graphics a standard feature in every PC. Their first chip, the NV1, launched in 1995, and it was a commercial flop. They acknowledged it failed to establish market leadership. The company nearly didn't make it out of the gate. But 2 years later, the Riva 128 launched, finally giving NVIDIA its first taste of success. Then, in 1999, came the game changer, the GeForce 256. NVIDIA boldly marketed it as the world's first graphics processing unit, the GPU. It was more than just a faster graphics chip. It was a fundamental shift in how computing could be done. The GPU was a different beast from the CPU. Where a CPU had a few powerful cores designed for sequential tasks, a GPU packed hundreds, even thousands of smaller, simpler cores, all working in parallel. This architecture was perfect for rendering millions of pixels simultaneously, making it ideal for the demanding world of video games. By 2000, NVIDIA had even acquired the assets of its major competitor, 3DFX, solidifying its dominance in the burgeoning gaming market. For the next 5 years, gaming was NVIDIA. It was a fiercely competitive, razor-thin margin business, constantly demanding more speed and visual fidelity. But beneath the surface, a quiet internal debate was brewing. Could these specialized graphics processors, so good at parallel tasks, be used for something else? Outside of a few scientific computing labs, the idea seemed outlandish. CPUs were the undisputed kings of general computing. Trying to make GPUs do anything else was seen by many, even within NVIDIA, as a distraction, a waste of precious resources. But Jensen Huang had a different vision. He pushed his engineers to invest in what seemed like an impossible dream, to turn the GPU into a general-purpose parallel processor. This wasn't about slightly improving graphics. It was about fundamentally rewriting how software could interact with their hardware. And so in 2006, NVIDIA launched CUDA, Compute Unified Device Architecture. CUDA wasn't just a programming language. It was a comprehensive software platform, a full ecosystem designed to let developers program GPUs for non-graphics tasks. It was a massive, expensive bet, requiring years of engineering and a leap of faith that developers would embrace an entirely new way of thinking about computing. And for years, the payoff was minimal. From 2009 to 2011, CUDA adoption grew slowly. Investors questioned whether this multi-year, multi-million-dollar investment would ever yield a return. Why pour so much into a niche capability when the gaming market was right there, demanding attention? Many analysts, and even some within NVIDIA, viewed it as a costly side project, a vanity experiment that drained resources from their core business. Yet Huang doubled down, convinced that parallel computing was the future, even if that future was still years away. Then in 2012, something completely unexpected happened. A team of researchers at the University of Toronto, led by Geoffrey Hinton, entered the ImageNet competition, an annual contest to classify millions of images with unprecedented accuracy. Their deep neural network, AlexNet, achieved a breakthrough performance, dramatically outperforming all previous attempts. And what was powering AlexNet? NVIDIA GPUs, running on CUDA. It wasn't just a marginal improvement, it was a monumental leap forward. AlexNet proved that deep neural networks could be trained orders of magnitude faster with GPU acceleration than with CPUs alone. This wasn't just a win for AlexNet, it was a seismic event, a sudden, undeniable validation of NVIDIA's decade-long gamble. The obscure, unloved CUDA ecosystem suddenly became the key to unlocking the power of artificial intelligence. The world, it turned out, had been building the ultimate parallel processing problem, and NVIDIA had been quietly building the ultimate parallel processing solution. The AlexNet breakthrough was the spark, but it was the years of patient, unyielding investment in CUDA that became NVIDIA's fire. When deep learning truly exploded into the mainstream around 2016, NVIDIA wasn't scrambling to catch up. Their ecosystem was already mature. Researchers worldwide already knew how to program their chips. Their software tools, libraries, and developer community were years ahead of any potential competitor. Then came 2022, and with it, ChatGPT. The launch of OpenAI's revolutionary chatbot sent shockwaves across the globe, instantly demonstrating the immense power of generative AI. The demand for AI training hardware didn't just increase, it surged, becoming a global gold rush. Suddenly, every major tech company, every cloud provider, every startup needed NVIDIA's GPUs, and they needed them yesterday. This wasn't just about selling chips. It was about an entire computing platform. From the silicon itself to the networking, the software tools, and the developer relationships cultivated over 2 decades, NVIDIA, once a gaming company, was now the indispensable infrastructure provider for the greatest technological transformation of our time. They had inadvertently built the supercomputers of the future, decades before the world knew it needed them. Today, NVIDIA's GPUs power the vast majority of frontier AI models. Their chips are the workhorses and data centers of every major cloud provider, from Amazon to Microsoft to Google. While they face competition from AMD, Intel, and even custom AI accelerators like Google's TPUs and Amazon's Trainium, NVIDIA's deep integration of hardware and software, especially CUDA, gave them an unparalleled lead. The 2020 attempt to acquire ARM, though ultimately abandoned due to regulatory scrutiny, signaled their ambition to expand further into diverse computing platforms. But even without ARM, NVIDIA has become central to AI infrastructure, expanding into networking, AI software, robotics, and comprehensive accelerated computing platforms. The company that almost failed with its first chip, that bet its future on an unproven technology, now stands as one of the most valuable companies in the world, not because of a single brilliant invention, but because of relentless, long-term strategic patience. NVIDIA's story is a testament to the power of long-term vision, even in the face of skepticism. It shows that sometimes the greatest opportunities lie hidden in plain sight, dismissed as niche or unprofitable until a sudden shift in technology reveals their true potential. Their success wasn't inevitable. It was forged through an obsession with engineering excellence, a willingness to make unpopular investments, and an unwavering focus on building an ecosystem for developers years before the market existed. It's a powerful reminder that in the fast-paced world of technology, true innovation often requires the courage to make a bet on a future that only you can see. What other companies do you think are making silent bets today that will shape our future? Share your thoughts in the comments below. And if you found this exploration of NVIDIA's journey insightful, consider subscribing to uncover more hidden histories behind the world's most influential technologies.